So let's see how to write the chemical formula. The shortest way to represent a compound with the help of symbols and valency of elements is known as chemical formula. Okay, so what do you mean by chemical formula? The shortest way to represent a compound with the help of symbols and valency of elements is known as chemical formula. Okay. Okay, so chemical formula of a compound show its constituent elements and the number of atoms of each combining element. In ionic compound, the charge on each ion is used to determine the chemical formula of the compound. So there are certain rules for writing the chemical formula, right? So there are some rules of writing the chemical formula, right? So let's see what are the different rules of writing the chemical formula. The very first rule is the valencies or charge on the ion must be balanced. Okay. Now, the second is when a compound consists of a metal and a non-metal, the symbol of metal is written first and on the left, whereas of non-metal on its right. For example, if we talk about calcium oxide, right? Calcium oxide, right? So how we write it as CaO, right? So whenever a compound consists of a metal and a non-metal, right? Oxygen is a non-metal, calcium is a metal, right? The symbol of the metal is written first on the left side, whereas the non-metal on its right side. So this is metal and this is non-metal, right? In this way we will write. Similarly, sodium chloride, NaCl, right? So we are writing symbol for Na first, which is metal, and then chlorine, which is a non-metal after this, right? So in this way we need to write, okay? Then the third rule in this is when compound is formed with polyatomic ions, okay? When the compound is formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. Okay, so whenever a compound is formed with a polyatomic ions, the ion is enclosed in the bracket before writing the number to indicate the ratio. For example, CaOH whole 2, right? So in case if the number of the polyatomic ion is 1, the bracket is not required. But if it is more, right? Okay, number of polyatomic ion is more, then we need to write a bracket here, as you can see here. Okay, and then we will write the number of that ion, OH ion, right? So if the polyatomic ion is just 1, for example, another example is sodium hydroxide, right? So here the OH ion is just one ion is present, right? So here we do not write any bracket, right? But here there are 2 hydroxide ions which are bind with the calcium ion, right? Okay, so in this way we can put the bracket here, but in sodium hydroxide bracket is not required. Is that clear? So these are certain rules which we have to follow while writing the formula of the compounds, right? Okay, so the fourth rule is if there is a common factor between the valencies, then valencies of the cation and anions, then what we do, we divide the valencies by that common factor. Okay, and then finally we apply the crisscross, that is the crossover of the valencies or the charges, so that they can appear on the lower right hand side of the symbols. Okay, so these are the certain rules which we have to follow. Now let's see how to write down the formula of simple compounds. Okay, so to write down the formula of simple compounds, we will first write the symbols of the constituent elements, okay, and their valencies. I will tell you in some examples now. Then write the symbol of the cation. First, cation is formed by the metals. So as I told you in the earlier rules, right? So metal symbol is written first, then followed by the non-metal. So metal forms cation and non-metal forms anion. So cation first, then followed by the symbol of anion. Then we use the crisscross. The charges are the valency to get the formula. Okay. So now let me tell you how to write it down, right? So let's see some examples. Now let's see the example. Hydrogen sulfide. Hydrogen sulfide. Okay. Now what are the symbols? First we will write down the symbols. Symbols for hydrogen is H, sulfur is S, right? Now what are the charges? Charge on hydrogen is +1. Getting that? Okay. And on sulfur, it is the valency, the charge is -2. Okay, so we will write like this. Okay, this is the sulfide ion, hydrogen sulfide. You can see the table which I told you, right? What is the charge on it, right? So sulfide is S2 negative. You can see here. Okay, and hydrogen is 1. So valency of hydrogen is 1, and it is for the sulfide is 2. Okay, so you need to learn this. Okay, so we have written the valencies here, the charge here, right? Now, how to get the formula? Formula will be, so what we will do, we will crisscross, right? We'll do the crisscross method here to here and here to here, right? And then we write down. So valency of S will be written here, H2, and valency of S will be here. So we do not write 1 here. It is understood if it is S, this is 1. Okay, so how we get the formula for hydrogen sulfide? This is H2S. Okay, so always remember, so when the subscript is the number 1, we do not write. It is not written, it is already understood. Okay, now similarly, for example, let's take another example. Carbon tetrachloride. Carbon tetrachloride. Okay, now what are the symbols involved here? Symbols are carbon symbol is C, chloride is Cl, right? Now what are the charges? Charges is on carbon, charge is +4. On chlorine, it is -1. You can see the table. Okay, then we use the crisscross method. Okay, and valency will be interchange, right? Okay, so we will write C, right? Since it is 1, so we do need not to write it 1 here, and Cl, and it is 4, so we will write down here 4, right? So what will be the formula? Carbon tetrachloride is CCl4, right? So what does it mean? It means that one carbon atom is combined with 4 chlorine atom, right? So tetra means 4, right? So one carbon atom and 4 chlorine atoms are attached to form carbon tetrachloride. Is that clear? So this is how we get the formula, the chemical formula for the compound using crisscross method, using the valencies, symbols, and the charges. Please note it down. See how they're combining, right? Like why we are writing these, valencies in a crisscross method, right? So what does it mean when we say H2S? It means that one sulfide ion is connected with 2 hydrogen atoms. Getting that? And that's why we are writing it H2S, right? So 2 hydrogen atoms and 1 sulfide ion are combined to form the hydrogen sulfide. 2 hydrogen ion and 1 sulfide ion combined to form hydrogen sulfide, right? Why it is so? Because sulfide ions are having 2 extra electrons. That is the reason it is having -2 charge. And each hydrogen atom have a deficiency of 1 electron only, right? Okay, so it's 1 electron is given to each one of these atoms, these ions, hydrogen ions. Is that clear? Right? Because hydrogen needs only 1 ion, 1 electron to complete its outermost shell, right? Okay, so 1 electron atom is gained by this hydrogen and 1 is gained by this hydrogen, and it was having 2 extra electrons, right? Okay, so it is giving its extra electron to these 2 these 2 hydrogen ions. Are you getting that? And that's the reason 2 hydrogen ions are connecting with 1 sulfide ions, and it is like H2S. Is that clear? Rudra, Anvi, and Sama, right? Similarly, CCl4, right? So what does it mean? Calcium having 1 extra electron, right? But carbon needs 4 electrons, right? It having a deficiency of 4 electrons, right? It needs to combine with 4 electrons to complete its outermost shell, right? So each one of them is given by the chlorine atom, right? So there are 4 chlorine atoms which are combined by the carbon atom, right? So 1, 2, 3, 4, like this. You can write like this, CCl4, right? Is that clear? Okay, so each electron, each chlorine atom, chlorine ion is giving one extra electron to carbon atom to complete it octet, right? So one electron is coming from here, one is from here, one is from here, one is from here. And that's how the deficiency 4 electron get filled and its outermost shell get complete, right? So in this way, right, the compounds are forming, and that's the reason we are just, using the crisscross method to write it wrong, right? So this plus 4 is going there. That means it is having the deficiency of 4 electrons, which is completed by 4 chlorine atom, 1 electron from each chlorine atom. Is that clear? Okay, so in this way, we are writing the formulas. I hope now you are getting it. Now let's see more examples. Magnesium chloride. Magnesium chloride. Symbol. What are the symbols of magnesium and chloride? Magnesium is Mg, chlorine Cl. Right? Now charge. Charge on magnesium is +2, whereas on chlorine it is -1. Right? So what we do? We'll do the crisscross method again. Right? Right? That means what? Magnesium having a deficiency of 2 electrons, whereas each chlorine is having 1 electron extra, right? So that's the reason one magnesium atom is combining with 2 chlorine atoms to form magnesium chloride, right? And what will be the formula now? Formula will be MgCl2. So we will write this 2 here, okay? Right? Representing that one magnesium atom is combining with 2 chlorine atom to form magnesium chloride. Okay, is that clear? Now similarly, another example. Calcium oxide. Calcium oxide. Okay. Now, what are the symbols? First, write down the symbols. For calcium, it is Ca. For oxygen, it is O. Right. Now, what are the charges? Charge of calcium is +2, whereas oxygen is -2. Right. Okay. Opposite charges. Valency is same, 2 and 2. Right. So, what will be the formula now according to the crisscross method? It will be Ca2O2. Ca2O2. But since, as I told you, that whenever the ion, right, they are having a common factor, right? So if you can see, both of the valencies are having a common factor 2, right? Both are divisible by 2. So what we do, we divide the valency by that common factor and we'll write the formula, right? So instead writing Ca2O2, we will write it as CaO, dividing the valencies by 2, right? Because 2 is the common factor. Okay, so we do not write Ca2O2, we will write CaO. So CaO is the calcium oxide, right? So when the valency of both elements are numerically equal, we do this, right? The subscripts are not written, right? So we simply write it as CaO. Is that clear? Now let's see some more examples. Aluminium oxide. Symbol aluminium Al, oxygen O, right? Now what are the charges on these? Charge on aluminium is +3 and oxygen is -2. These are the valencies, right? Now we can use the crisscross method to write down the formula. So the formula for aluminum oxide is Al2O3, right? So what does it mean? That 2 aluminium atoms are combining with 3 oxygen atoms to form aluminum oxide, Al2O3. Is that clear? Okay, because aluminium is having a deficiency of 3 electrons. Getting that? Whereas oxygen have 2, right? 2 extra electrons, right? Okay, so we can use the crisscross method to write it down, and that's why the formula is Al2O3, right? Now, next is Sodium nitrate. Sodium nitrate. Right? So first we'll write down the symbol. Sodium is Na, nitrate ion is NO3. Now look at this nitrate ion. This is a polyatomic ion, right? Okay. Polyatomic means having more than one atom in an ion, right? Which is behaving as a single entity. Now charge on sodium is +1 and on the nitrate ion is -1. You can see that table for the charges, right? So nitrate ion is having -1 charge. Okay. Now again we can use the crisscross method and we will write down the formula as NaNO3. This is sodium nitrate, NaNO3. Okay, so this is sodium nitrate, formula for the sodium nitrate. Please write down. Now let's see more examples. Potassium carbonate. Potassium carbonate symbols are potassium is K, carbonate ion is again a polyatomic ion, CO3. Charge on potassium is +1 and on carbonate ion is -2. Now we can use the crisscross method again. And we'll write down the formula. That is K2CO3, right? So what is potassium carbonate? K2CO3. Next example. Aluminium hydroxide. Aluminium hydroxide. Symbol. Aluminium is Al. Hydroxide ion OH. Okay. Charge. Again, OH is a polyatomic ion, right? Charge on aluminium is +3 and hydroxide ion is -1. So the formula will be, by using crisscross method, it will be Al, right? So as we know that here, what we are having? OH, right? Okay, so what we use? Bracket here, OH whole thrice. Okay, so write down. Another example, ammonium sulfate. Ammonium sulfate, right? Symbol ammonium NH4, okay, polyatomic ion. Sulfate SO4, both are polyatomic ions. Now charge on ammonium ion is +1 and on sulfate ion is -2. Okay. Now using the crisscross method, the formula will be NH4 whole twice, okay, SO4. Okay, NH4 whole twice SO4, right? So why we are putting the bracket here? Because this is a polyatomic ion having valency more than having, because the charge using the crisscross method, it is more than 1, right? So we need to put the bracket here. Okay. Now next example, tin 4 oxide. Okay. Symbol tin, that is Sn, valency +4, oxide O, valency -2. Okay, then we use the crisscross method. Now the formula will be Sn2O4. Now look at the valencies here. 2 and 4, both are having a common factor 2. So what we do? We will divide both of them, both the charges, both the valencies by 2. And that's why we simplify it and we'll write it as SnO2, right? So tin 4 oxide is SnO2, right? So tin 4 oxide means the valency of tin here is 4. So that's why we are writing here 4, right? So sometimes the element is showing more than one valencies. So in such cases, we generally write down the valency in the bracket. Okay, please note. So after writing the formula, let's see what are the molecular mass, right? And how to write down the molecular mass, how to find out it. So molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of that substance, right? So what is a molecular mass? It is the sum of the atomic masses of all the atoms in the molecule of that substance. That means it is therefore the relative mass of the molecule expressed in atomic mass units, because atomic masses are relative atomic masses, as I told you earlier, right? Okay, so molecular mass is the relative mass of the molecule, which is expressed in AMU, right? Okay, so write down. We express molecular mass in AMU, atomic mass unit. Okay, for example, the relative molecular mass of water. How to find the relative molecular mass of water, right? So write down relative molecular mass of water, H2O, right? So how to find the relative molecular mass of water? It can be calculated as like atomic mass of hydrogen, atomic mass of hydrogen, right? Plus atomic mass of oxygen, right? Is that clear? So atomic mass of hydrogen is 1 and atomic mass of oxygen is 16, right? But this water molecule, H2O, it contains 2 hydrogen atoms and 1 oxygen atom. Yes or no? Is that clear? It contains 2 hydrogen atoms and 1 oxygen atom, right? And each hydrogen atom is having atomic mass of 1 AMU, right? And each oxygen atom is having the atomic mass of 16U. Getting that? So how do we find the molecular mass of the water molecule? We will multiply 2 and 1, right? Because there are 2 hydrogen atoms, plus 1 into 16, 1 oxygen atom. Is it clear? 2 into 1 plus 1 into 16. And that's how this is 18U or 18 AMU. Both are same thing. Okay, so in this way we can find out the relative molecular mass of a hydrogen of the water molecule, right? So since water is a compound, so we need to find the molecular mass, means mass of the molecule of water. And in this molecule of water, there are 2 hydrogen atoms and 1 oxygen atom, right? So if we find out the sum of all the atoms which are involved into that molecule, we will get the molecular mass of that molecule. Is that clear? Yes or no, please. Suppose, next example, we have to find the molecular mass of ammonia. Molecular mass of ammonia, right? Okay, so what is ammonia? Ammonia is NH3, right? This is ammonia, right? Now, if you can see here, there is in this molecule, one molecule of ammonia is containing 4 atoms, 1 nitrogen atom and 3 hydrogen atoms, right? So what will be the molecular mass of this molecule of ammonia? That will be 1 into atomic mass of nitrogen, which is 14, right? So write down atomic mass of nitrogen is 14 and atomic mass of hydrogen is 1, right? So when we are saying 14, it is AMU, 1 AMU, right? Okay, so how do we write? How do we find the molecular mass of ammonia? 1 into 14, because there is 1 nitrogen atom, and we will add 3 into 1, right? Because there are 3 hydrogen atoms, right? And each hydrogen atom is having a atomic mass that is 1 AMU. Getting that? So now you can add this 14 plus 3, that is 17 AMU, right? So what is the molecular mass of ammonia molecule? It is 17 AMU. Is that clear? Are you getting this? Yes or no? Let's take another example. Suppose we have to find the molecular mass of sulfur dioxide. Molecular mass of sulfur dioxide. Okay, that is SO2. Chemical formula is SO2, right? Now, again, we should know what is the atomic mass of sulfur and atomic mass of oxygen, right? So, in this one molecule of SO2, there is one sulfur atom and two oxygen atoms, right? Okay. So, first we will write down like what are the atomic masses of each one of them. So, atomic mass of sulfur. What is atomic mass of sulfur? That is 32. Okay. And atomic mass of oxygen is 16, right? Okay. Atomic mass of each atom of oxygen is 16, right? Now we can write down the molecular mass. Therefore, molecular mass of SO2 will be equal to 1 into 32 because there is one sulfur atom, right? Plus 2 into 16 because there are two oxygen atoms, right? That's why we have multiplied with 2. Is that clear? Now we can solve this. So 32 plus 32, right? That is 64 AMU, right? So what is the molecular mass of sulfur dioxide? That is 64 AMU, right? So in this way, we can find out the molecular mass of any of the molecule of any compound. Is that clear? Yes or no? So now let's see what is formula unit mass. Formula unit mass is the sum of the atomic masses of all the atoms present in the formula unit of a compound, right? Formula unit mass is calculated in exactly the same manner as we calculate the molecular mass. There is no difference. Just that the difference is that the word formula unit of this word, instead of molecular mass, what you are using formula unit mass. Instead of using molecular mass, we are using here formula unit mass. Right? So this formula unit word is used for the substances whose constituent particles are ions. Are you getting that? So when the constituent particles are ions, instead of using molecular mass, we use the word formula unit mass. That is the only difference, right? How to find it? We will find it exactly in the same way as we are finding the molecular masses, right? Again, here it is the sum of all the atomic masses of all the atoms present in that formula unit of a compound. Is that clear? So write down. Okay. So we find the formula unit mass exactly in the same way as we are finding the molecular mass, right? The difference is that here the word, the formula unit, here the word formula unit, this word is used for the substances whose constituent particles are ions. Okay, so these are used for ionic compounds, right? So if we talk about the example of formula unit mass for sodium chloride. Okay, sodium chloride is an ionic compound, right? NaCl, right? So instead using molecular mass, the word molecular mass, we use the word formula unit mass because its constituent particles are ions, right? And we find it exactly in the same way. So there is one sodium ion and one chlorine ion, right? So we will write down the atomic masses of each one of them. So atomic mass of sodium is 23. So Na is one atom, right? So 1 into 23 plus, now atomic mass of chlorine is 35.5, right? Okay, because of the presence of the isotopes, right? So we'll write it as 1 into 35.5, right? Now we will add them. So this is 23 plus 35.5, and this is equals to 58.5 U or AMU. That is the same thing, right? So it is just the difference of the name, formula unit mass or molecular mass, right? So whenever the compound is an ionic compound, instead of using the word molecular mass, we use the word formula unit mass, right? And we find it exactly in the same way as we are finding the molecular mass of the molecule of a substance. I hope everybody is clear with it now. Yes or no?